Can you hear me?
Can you hear
Hello?
me? Yes,
Oh
I
yeah,
can
I
hear you.
can hear you. Okay. I just had a question. Would I need to buy a webcam or is the camera on my laptop fine? Because I know you said that you would need to see like the desk
Right,
and
right. The camera on your laptop should be fine.
okay.
Um, or you can also use the camera on your your phone. So if you have a camera on your phone, that should also be sufficient.
Okay, sounds good. Thank you.
Okay. So no, you don't need to purchase a webcam or anything. Other questions about anything? Okay. Okay, so let me see. So let's start chapter 1. Oops. Let me start chapter 1. Introduction to statistics. So section 1.1, statistics and critical thinking. So what is statistics? Well, there are two major branches of statistics: descriptive statistics and inferential statistics. So descriptive statistics, well, somehow describes your data. It consists of designing experiments, collecting, organizing, summarizing, and presenting data. It's basically the first half of the course. Chapters 1 through 5 describe descriptive statistics. Inferential statistics consist of generalizing from samples to populations, performing hypothesis tests, determining relationships among variables, and making predictions about a population from a sample. It's basically, well, the latter half of the book. Now, if you notice, well, inferential statistics is really sort of the interesting thing. It's really doing something, making inferences from a sample to tell you something about a population. And well, why don't we just do inferential statistics? Well, it turns out that the techniques necessary to do inferential statistics are really the techniques that we learn using from descriptive statistics. So I first have to tell you about descriptive statistics in order for me to be able to do inferential statistics. So this first sort of chapter is really terminology. So this first chapter, I would say, is different than the other chapters in this book, the other modules that we'll cover in this course. It's really purely terminology. So what you'll notice is that, and I guess I should say this about statistics in general, you'll be getting a lot of terminology. And, I'll just sort of try to give it in context as much as possible. But what will happen is that, we'll give you all these sort of terminology, and you're sort of say, yeah, okay, this is sort of obvious, all this terminology. But then in the later chapters, we'll use all this terminology. So you may need to refer back to this chapter in the future, because then it will become evident why I'm giving you this terminology. And the basic reason why we're giving all this terminology is because, well, differing data will be, we will use different techniques on the differing data according to these differing terminologies that I give you. And so we need to classify our data so that we can use these different techniques to solve our particular problems that we pose. And so you need to know, or at least be able to eventually understand these different terminologies that we give you. So at the beginning, you may not really appreciate some of this terminology, but it'll become evident as we go further into this course why I need to cover these terminologies. Okay, so variables. A variable. Oh, and I guess I'll also say that I will be giving further definitions to clarify some of these definitions. So at the beginning, some of these definitions will be less specific than they should be. But until you have enough sort of general background, I first need to give you sort of hand-waving terminologies before I can give you more specific terminology. So a variable is a characteristic or attribute that can assume different values, such as height, weight, temperature, a number of phone calls. These are examples of variables. A variable whose values are determined by chance are called random variables. And again, I will define random variables several more times, each time becoming more and more specific what I really mean by a random variable. Data are observations, such as measurements, genders, survey responses that have been collected. Statistics. Well, statistics, there'll be several differing ideas that have the name statistics. This is an additional one. So statistics is a collection of methods for planning experiments, obtaining data, and then organizing, summarizing, presenting, analyzing, interpreting, and drawing conclusions based on the data. So first, a population. What is a population? Well, a population is a set. It is a complete collection of all objects that you are studying. So the collection is complete in the sense that includes all the subjects to be studied, such as people, measurements. A census. A census is the collection of data from every member of your population. A sample is a sub-collection of members selected from the population. A sample is a subset of the population. So let's do an example. The Gallup Corporation collected data from 1,013 adults in the United States. Results showed that 66% of the respondents worried about identity theft. So the question is, well, what is the population? So I guess I'll ask you, what is the population? We have that they collected data on 1,013 adults in the United States, showing that 66% of the respondents worried about identity theft. So what is the population?
Is it adults?
Adults. Yes, adults in the United States. So the population is adults in the United States. So the population consists of all 241 million adults in the United States. So this is the population. What is the sample? So in this case, what is the sample? Maybe one.
1,013 adults.
Oh, well, okay, you can say that the sample consists of 1,013 adults. It really consists of that 1,013 adults in the United States. So it's a subset of the population. So it's the 1,013 adults in the United States that were sampled. What is the objective collecting this sample data? So, what do you want to answer? Well, anyone? So what's the objective?
To find out who worries about how many people worry about identity theft.
Actually, the percent that worry about identity theft. So the objective is to determine the percent of adults in the United States that worry about identity theft. And the way that we do that is that we collect sample data and use this sample data, these 1,000 adults, to draw some conclusion about the whole population. So we want to know something about the population. I don't really care about those 1,000 people. What I care about is all adults in the United States. So I want to somehow figure out of adults in the United States, what percentage of them worry about identity theft. Maybe these 1,013 adults will give us an indication of how many adults in the United States, what percentage of the adults in the United States worry about identity theft. So we want to use this sample data to draw a conclusion about the population. Any questions about that? So a parameter. A parameter is some numerical characteristic about a population. So here are examples of parameters that you will encounter in the future in this course. The population mean, denoted by the Greek letter mu, mu. The population standard deviation, denoted by, and this is a lowercase Greek letter of mu. The population standard deviation, denoted by the lowercase letter, Greek letter, sigma. The population variance, denoted by sigma squared. The population correlation coefficient, denoted by the Greek letter rho. And the population proportion, denoted by p, or sometimes people denoted by the Greek letter pi. So in the future, we will have these concepts defined. A statistic is a numerical characteristic of a sample. So for a parameter, it's a numerical characteristic of a population, whereas a statistic is a numerical characteristic of a sample. And so some statistics that we will encounter in this course are the sample mean, denoted by a bar, the sample standard deviation, denoted by the letter S, the sample variance, denoted by the letter S squared, the sample correlation coefficient, denoted by the letter R, and the sample proportion, denoted by a caret. So one of the things that you should note is that, well, if I look here, notice for population standard deviation, it is the Greek letter sigma. For a sample standard deviation, it is the letter S. The Greek letter for S is sigma. And for sample variance, is that squared? Population variance, sigma squared. So again, sigma is the Greek letter for S. The sample correlation coefficient is R. The population coefficient, correlation coefficient is, well, the Greek letter for R is rho. And then we have symbols. So, you know, we have like a bar here, a caret. And so we may also have some sort of symbols that will indicate a particular parameter or statistic. So that finishes off section 1.1. Any questions on the terminology in section 1.1? Oh, and I guess I should say, if you go to section 1.1, here are the lecture notes for, in this particular case, section 1.1. I have, well, a previously taped version of the lecture. I just sort of taped this lecture maybe last year or something, and I downloaded it or uploaded it. So you can see that. I also have the, if you say, it says up here, click here for the PDF. That's basically a PDF that I've been looking over. And, oh, this is another person doing the same thing at a different college. And I give, well, slightly further detail of things that I've talked about. Okay. So for each sort of section, we have those lecture notes. Okay, any questions on section 1.1?